All right, in this lesson, we're going to be graphing our logarithmic functions. So our basic logarithmic function here is just f of x is equal to the log of some base of x. That's just kind of the easiest one to graph, is just the log any base of x. Now, we're going to kind of talk about two functions really quick and just graph these two. We're going to start with our exponential function. We did skip this unit. We did not do this, but you have graphed these before in 9th grade. So if you'll remember clear back 2 years ago, when you graphed this exponential function right here, 10 to the x power, I would just plug in a few x's. Okay, my favorite x to use is 0. We can even draw an xy table here. So when you plug in 0 here, 10 to the 0 power is 1. So when x is 0, your y is 1. There's a point on our graph. Okay, my next favorite one is just 1. When you plug in 1, 10 to the first power is 10. So it's going to get pretty high. 3. It's going to shoot up there. 10 to the negative 1 power, remember we make it a fraction, it's going to be 1/10. It's going to get really close to 0, but if you'll notice here, this graph, when we graph it, it's never going to be negative. Our y values are never going to be negative. It'll have what we call an asymptote right there and then just shoot up really high. So that's what our lovely exponential function looks like right there. Now we've talked about how logarithms are exponents. Basically, if you were to graph the logarithmic function of this, it's just going to be its inverse, which means it gets reflected over this y equals x line. So if we were just to reflect this and flip all these points over this line over here, it would look like this. But I'll show you how to grab 2 points on there too. But just when we reflect that 10 to the x power over our y equals x line, our logarithm function will look something like this. Now, there are 2 points that I want to talk about though, because we could do this as well. We could have our x and y. Basically, you could, when I'm doing this, I would actually turn this back into my exponential function. Basically, these are all just inverse. When x is 1, y is 0 over here. If you just switch some forms right here, so when my x is 1, my y is 0. When x is 1, y is 0 right there. When my x is 10, y is 1. So when I go out here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I didn't make it quite as steep as it should be. It should be that's just up 1 right there. Okay, so those are 2 points. And basically, I'm going to have you graph everything using those 2 points. Please note that anything to the 0 power is 1. So when you're graphing a logarithmic function, unless it's translated and moved up and down and over and in, but 1, 0 is always going to be a point on your graph. And then the other point is going to be whatever the base is. So this is my base 10 right here. Whatever that base is, always goes to 1. So anything to the first power is itself right there. So I only want, when you're graphing these on your assignment, I only need 2 points, 1, 0, and the base 1. You might have to move them around after we show you some translations, but let's show you how this works on this first example here. Okay, so if we're graphing this log base 3 of x, again, there's 2 points that you want right here. I'm going to have you graph those 2 points just right off the bat. So your 1, 0 is a point, and also your base 1. So my base right here is 3, so 3, 1 is a point. So 1, 0, and then 3, 1. Please note the picture, what it's going to look like. Notice it's going to go down really close but never cross that lovely y-axis, which means that you cannot take the log of a negative number, by the way. We'll talk about that more next unit. But then this one's going to keep going forever this direction and go down forever that direction. So that's your picture right here. So your domain in what we call the parent function, if we're not adding anything to this or adding anything to our x right here, your domain, or you have this lovely asymptote, your picture is never going to cross this x equals 0 bar. So your domain here just goes from 0, we're at, I'm writing this all wrong. We're not going to include 0 because it's going to go really close to 0 but never really touch 0. I know it looks like it touches, but pretend it doesn't look like that, to infinity. So your x's right here, they keep going down. They're never going to be negative. So they just go from 0. This does go forever to positive infinity. Your range, however, is going to be all numbers. See how it goes down forever? This is going over forever, but it's also slightly going up forever. So it'll go forever both directions. Okay, your x-intercept, wonder if I'm going to cross this off. I don't care about the x-intercept, so let's not use that one for our homework this time. I do want the asymptote. Now you're saying, well, the asymptote is just 0. On this one it is, but we are going to show you some examples where the asymptote actually moves. Your whole graph will move right or left. So the asymptote right there is just where x is equal to 0. And this picture is always going to be increasing or decreasing. We'll show you when they're decreasing, but for this one, it's not decreasing at all, but the increasing, it's always going to be your domain. Wherever the function exists, that is where it's going to be increasing. This end behavior is a little bit trickier. Okay, so what you're going to do, I didn't even write it like I normally do. I usually just leave a place for you to write in your blanks, but there's going to be two ends. Okay, so I'm just going to write it as x approaches something and x approaches something else. Now, these ends are always going to be your ends of your domain. Okay, so when x approaches 0 is going to be one of the ends. See how x is getting really close to 0 right here? That's this end on the left. As x approaches infinity, that's your end on the right. Okay, so what I want you to write, they'll always just be those two values, the domain, so they could change a little, but your y or your f of x is going down. See how that's going to negative infinity over there by 0? And then over here by positive infinity, it doesn't look like it, but it's slowly going up. Okay, it's just going to keep going up really slowly, but it is going to positive infinity. All right, let's take a break there. We'll graph a couple more on our next video.